Hey everyone. So before we get into our next lesson, I wanted to talk to you about something that's called the step pattern. So when we are graphing and when we are reading the graph of a parabola, we are going to be using the step pattern, and I just wanted to explain kind of where it comes from. Okay. So I've gone ahead and I have plotted our graph here. Y is equal to x squared, and I've included 3 points on either side of the graph. Okay. Let's just zoom in for a little second here. So first things first, I want you to just appreciate that every point that I have is increasing by 1 horizontally. Okay, so I can see that the step here is from 0 to 1, 1 to 2, and 2 to 3. Same to the left, 0 to -1, -1 to -2, and -2 to -3. Those are all increasing by 1. Okay, that's not really the most important part here, but you just need to appreciate that before we get started, okay? The purpose of the step pattern is actually to tell you the difference vertically between all of the different steps, okay? All of the different points. So here, I have a step of 1, okay? From 0 to 1, I'm going up by 1. Let's now go from 1 to 2 horizontally. That step is actually 3, okay? And now we're going to go to our third step here. That step is 5. So we have a pattern of 1, 3, 5. And this is going to be true on the left-hand side of your parabola as well. As you can see, I go up by 1, I go up by 3, and I go up by 5. Okay? So regardless of which direction you're going, left or right, these are the steps that you can follow when you are graphing your parabola. And the pattern, the base pattern, okay, the pattern of your parent function is 1, 3, 5. And that's what we're going to be using to graph and then to read the graphs of your parabola. Okay? So as you can see here, in order to graph, I would be going to the right by 1, up by 1. Right by 1, up by 3. Right by 1, up by 5. And then I would do the exact same thing to the left-hand side. And that's because my step pattern is the same. Okay? Sometimes your step pattern might change. And let's look at an example where that is the case. Okay? So let's just hide this parabola and let's look at example number 2. So here I have, this time around, I have y is equal to 2x squared, okay? So it is a little bit more narrow. It is vertically stretched in comparison, okay? And let's take a look once again at our horizontal steps just to double check. So I'm going 0 to 1, 1 to 2, okay? I'm going 0 to -1 and -1 to -2. So we are moving as expected, okay, to the left and to the right by 1. Okay, now let's look at our vertical steps this time around. So our vertical steps here, okay, instead of going up our first step by just 1, as it was in the traditional parent function, I'm actually going up by 2. And next, I'm going up by 6. And this is the exact same case on the left-hand side. I go up by 2, and then I go up by 6. So my step pattern is 2, 6, whatever it would be. Now let's think, what was your original step pattern? Well, the original step pattern was 1, 3, 5. What's the difference between those two step patterns? Well, obviously our current step pattern has a factor of 2, a multiplication of 2 being applied. 1 times 2 is 2, 3 times 2 is 6. And so then I can predict that the next step would indeed be 10, because 5 times 2 is 10. And the 2 happens to match with the 2 that is in front of our parabola there, that is our A value. So the A value is going to dictate what the step pattern is for us, okay? So when you're given your equation, your A value is going to determine how quickly or how slowly you are moving up, because it is affecting your step pattern. Likewise, when you're given a graph and need to find the equation of the graph, you need to deduce the A value by reverse engineering what the step pattern is going to be. And again, the basis for the step pattern is that you are always moving horizontally up by 1. Your steps are by 1 and by 1 to the right. Okay, and we'll do some examples with that, but I just wanted to give you a brief overview on what the step pattern is and where it comes from. Okay, thanks for watching.